Let's talk about databases in cloud. Most of the application you are using would have some type of databases behind the scene. Databases is a good way to store data in a structured format so that if required, we could track back that data, we could query that data and get the result and maybe satisfy business or technical requirement of my application. So let's see how we have different type of database options in the cloud, how we implement these solutions in cloud. But before we discuss about implementation details, we need to understand some of the basic difference in the way databases store data. And that brings us to discussion of talking about SQL versus NoSQL databases, or I would prefer to call them relational versus non-relational databases, right? What we are discussing here is a pattern how the data is being stored inside a database. Like if you look here, this looks like a tabular format of storing data, whereas this side here, it looks like a hierarchical format of storing the data. The data may be same, but the way we store could be little differently implemented. Now, I personally don't prefer to call them SQL versus no SQL because now our non-relational databases have evolved so much that even they can understand SQL. So you could run a SQL query on a traditional relational database, or you could also run SQL query through some type of engine or some type of middle layer in between, so that your non-relational database will also split or will also spit the output into a SQL format. So that's why I prefer to use relational versus non-relational rather than calling it SQL or no SQL. Let's try to understand the pattern of data by using an example. Let's take a recipe card here. This recipe card is for making a banana bread. On one single page, I am getting details about the ingredients required. I am getting details about the steps to follow and more information like how much time it takes, is it easy recipe, how much it would be sufficient for. So this is one single page in a recipe book in which all the detail to make banana bread is there. I don't have to keep on going to different pages into the recipe book. One page is good enough. If I keep on following and if I all ingredients, I would have the banana bread baked up for me, right? I haven't tried this, I've just taken the picture, but in case you try this, let me know how this bread tastes and maybe I can give it a go. Now, let's focus on these ingredients. Now, you may be thinking why I'm talking about banana bread and all. I would relate these concept into a minute and I will explain you that how this is representing a type of database. So in this case, if I have to get these ingredients required for banana bread, obviously I have to go for grocery shopping. If I go to grocery store, what you will find that they have stored these items in different racks, and I may have to go to different racks and then what I am looking for. So maybe for banana, I would get it from here. Maybe I need drinks like milk and all, I would get from here. Maybe I need some crisp, may I need some cheese. So what I'm doing, I'm filling up my shopping cart by items which are coming from different racks. Think of these racks as your tables in which your data is stored. And you run a SQL query, which is your shopping cart. And to satisfy the query, what would happen? Probably that your data may be pulled from multiple tables, combined together and then delivered back to you. That's what is a traditional SQL database is. Here, the data is being stored into different tables, and when you run query, that time there would be some way by which your SQL engine running behind the scene will pull up data from all these locations, massage it as per the way you want or as per the query you requested, and then deliver that data to you so that you could process it further. So idea here is my data is spread, and obviously there may be some relationship between these tables, like probably these two things needs to be kept cool, so they would be kept nearby, so that this will be maybe whole cooling fridge, right? Just giving an example, it could be anything, but there is some relationship between these things which are being stored inside these table. On the other hand, when I had my banana bread recipe, I did not had to go to different places. Just one page has all the information. This is a type of a non relational database which is into play. In one document, I am getting all the information I need, whereas in case of a traditional relational database, my data would be spread across multiple tables, and then I would be running query which will bring data from different places and deliver me the result if I am looking for what I am looking for. Right. So differentiation between them. SQL databases are optimized for storage. What I mean by that, I'll explain that in a minute. NoSQL are optimized for performance. I'll explain that too. Now, data storage in terms of SQL database is rows and columns. All my data is stored into rows and columns, and I would have tables, and through these tables my data would be stored. So let's say this is my music table, and then there is a artist information here, maybe album information here, and that's how I would create relationship between these databases, and that's why they are called relational databases. These are all representing different tables, and by combining a table and then running query against it, I would get the result. Whereas if I'm talking about NoSQL database, maybe NoSQL database stores my data in a document format like a recipe card. And then everything is available here. If I'm looking for, let's say, year for Jane Doe, first and last name, I would just need to go to one document and I would get this information. Whereas in this traditional way of doing things, maybe the name is stored in this table, maybe the year is stored here, and maybe the ID is stored here, and there would be some relationship between these tables. So hope you are getting the idea. Now, let me explain what we mean here by SQL databases are optimized for storage and NoSQL databases are optimized for performance. Let's talk about it. Why this is. Let me show you a picture here. If you're guessing, this looks like very old picture by the way people have dressed and the way it looks, the black and white kind of a stuff, lot of manual work happening, and it has something to do with technology. As I can say, this is IBM Data Processing Division. What you are witnessing here, it is a 5 MB hard drive being shipped from IBM. 5 MB. Imagine that. So 5 MB hard drive is being shipped from IBM, and this was called a portable hard drive. Yes, it is portable with 8 men and 1 van. It is portable. Now, what we are trying to explain here that how storage has evolved. See this picture now. What you are seeing here on your fingertip, there is a 1 terabyte memory card. So in early days of computing, storage was very costly. Very huge cost was there for storage. So whatever systems were designed, they were designed in a way that they would optimize storage. Instead of keeping data in duplicate fashion, they would ensure that data is kept uniquely, and then we build relationship on top of that data to get that information. And that's what I meant when I said my SQL databases were optimized for storage. They were trying to minimize the space consumed for storing data. Whereas, so in SQL databases, we expect that transactions would be happening, and they use a very specific word to explain transaction that is called ACID support. So that is called atomicity, consistency, isolation, and durability. So that is a beauty of SQL database, that every transactions are happening either all or nothing. Only valid data is saved. If there is inconsistency, it won't be tolerated, it won't be saved. Transactions do not affect each other. So from my account, if I initiated one transaction of transferring $100 and another transaction was to receive $10, they are both treated separately, and you would have durability, which means return data won't be lost. This is what we refer as a ACID compliance. Now, this may not be very prominent now, because obviously SQL databases support it, but this support is also coming to NoSQL. Some NoSQL databases support this type of transaction too. So I won't say that it will always be true, because if I'm talking about Amazon based services like DynamoDB, in DynamoDB transaction support is there. You could follow transaction, but in technical term, this type of databases are referred as base compatible. Like acid and base in chemistry, kind of opposite. Same thing here. This is basically available. System does not system does guarantee availability, which means your data would be available. Right, but it can be into soft state. It may change over time. Don't worry if you don't understand the soft state, we would talk about it. And your data may be eventually consistent. Maybe in a while everyone would have the same data available, but there may be a transitioning phase where some node may have the latest data and some node may still have old data. So that is the difference between SQL and NoSQL, or relational and non-relational database. We can go into more technical details of differentiation, but I think it is a good enough point to get started now. So hopefully this thing is clear. And in the next topic, we will discuss about the way AWS implement databases into cloud. So I hope you enjoyed, and I'll talk to you into the next section. Thank you.